All right, here we are with the third and maybe not the last negative exponents video. All right, so we're going to put everything together that we talked about. We are going to have instances where we need to simplify. We're going to have negative exponents. We're going to have to use the power rule, the product rule, all those things. All right. The thing is, before you simplify any of these, you want to make sure that all your exponents are positive. All right. Our first example should look fairly familiar, even though it really doesn't look like something we've seen before. What I want to do first with this is go ahead and make my exponents positive. So that means that my a to the third power is going to move to the denominator, and my a squared is going to move to the numerator. Now that you see it, you see that it's exactly the same as the very last thing I did in negative exponents too. In fact, it's the same variable. So here I have two a's. That's what a squared means. On the bottom, or denominator, I have three a's. And I can cancel one on the top with one on the bottom, so one here, one here. One here, one here. Now remember, when they cancel, they actually cancel out to 1. So I actually have a 1 left over on the top, which means I still have 1 over a. The exact same answer I got in the last video. All right. Next example here, I would love for you to try it first, and then go ahead and watch me work it out. So go ahead and do that. All right. So I'm going to do the exact same thing I have been doing with it. I'm going to go ahead and say, okay, this whole piece is to a negative exponent, which means the whole piece needs to move to a denominator. And I'm going to keep it in the parentheses, but I'm going to change my exponent to positive. In the denominator, I have a b to the negative 3, which means it needs to move up top as a positive 3. Okay, I can't do anything yet, even though it's tempting with the b's. I need to go ahead, and this is now the power rule, and I need to go ahead and get rid of those parentheses. So remember that these exponents are 1, and if I have a base to a power multiplied by another power, I multiply those exponents. That's rule number 2, or power rule. Okay? Which means I have in the numerator, I have my b cubed. In the denominator, I have a to the 1 times 2, or a squared. And I have b to the 1 times 2, which is b squared. Once I have it here, now I can go ahead and simplify. All right? I'm going to write them out for a while. There's other ways to go ahead and do that. But for right now, I'm going to say, okay, on the top, I have 3 b's. I'm not going to have any a's to cancel, so I'm not going to bother writing the a's out. But I have 2 b's. The same thing is now going to happen. I'm going to cancel 1b for 1b. Doesn't matter which one you do, as long as 1 is in the numerator, 1 is in the denominator. I have another set to go ahead and cancel out. My leftovers is what I'm going to use for my final answer. So on the top, all I have left is a b. In the denominator, all I'm left with is my a's. And that's my final answer. I don't need to do anything else to it. I'm only going to do one more of this kind. We'll be practicing in class also. This looks awful. Please pause the video. Please try it. Make sure you write out as many steps as you can before you go ahead and watch me do it. All right, so I'm not going to treat this any different. All right, I'm still going to go ahead and write my fraction bar out. Now this whole piece has a negative exponent. Everything's in parentheses. So everything needs to go in the denominator as it's written, with the exponent now changed to a positive. All right. The second one, my exponents are already, my outside exponent is already positive. Right, so it doesn't necessarily have to move because of this exponent. So for right now, I'm just going to write it down. And we'll put a 1 on top here to make our life easy. Now both of these require the use of the power rule. And sometimes it's helpful to work them out separate. So I have a squared b to the third squared. So I have a to the 2 times 2 and b to the 3 times 2, which will give me a to the 4th, b to the 6th. That's this right here. The second piece, I got a to the negative 3, b to the negative 4, to the positive 3, which means I have a to the negative 3 times 3, which is a to the negative 9, and I have b to the negative, to the negative 4 times 3, which is b to the negative 12. Okay, so let's put it back together again. And I have a 1 in the numerator, and I have an a to the 4, b to the 6 from this. I have an a to the negative 9, b to the negative 12. Now I have negative exponents here. They all need to move to the top. Sometimes I like to be a little particular because I see that things are probably going to cancel. So I'm going to make sure to line my a's and b's above each other. Okay? And so I'm going to go ahead and move my a to the negative 9 up to a positive 9. My b to the negative 12 is a positive 12 in the numerator. And then I have a to the 4, b to the 6th. Okay? Now, you can write them out in 1-for-1 cancel, and that's totally okay. I'm also going to show you a little trick. This little trick is called the quotient rule. Now, you don't necessarily need to memorize this at all, but it will help you not to write out this a 9 times, or this b out 12 times, or this b out 6 times. You don't want to do that, okay? What the quotient rule tells you, if you have some base a to the m divided by the same base but a different exponent, you are allowed to subtract the exponents. Let's see how this works real quick. Okay, and if you're still confused with the quotient rule after this, that's fine. We'll be working with it a little bit more if you need to. Okay, so no worries on this. This means I have this piece here is going to be, now when this rule happens, this is all in the numerator. So let's think of it as a whole number. I have a to the 9 minus 4, which would give me a to the 5th. I also have b's. So I have b to the 12 minus 6, which is b to the 6th. And so my answer is actually going to go ahead and be a to the 5th, b to the 6th, and it'll be over 1. And the reason why it'll be over 1 is, notice my exponents in the denominator, these guys, are smaller than my ones in the numerator. And if you write this over 1, it's not incorrect. But this is what we're going to work with again. So if the quotient rule is hazy, that is totally okay. We are going to work more with simplifying these fractions, all right? And not necessarily as a negative exponent type of thing, just in general. So we'll be working on this a bit after we get more practice. I will see you in the next video.